Measurement of angle A. If you measure it like I showed you using the protractor, and you measure angle A up here, you put, A prime, measurement of angle A prime right here, and you turn it around, you will see that the degree is 75 degrees. And if you measure angle B, it'll be 60 degrees. And then subtract that, you get 135, and minus 180. 135, and minus that from 180 of a total angle of all triangles, it equals to 180 degrees, you get 45 degrees. So compare the triangle to the primes to the regular pre-image one. What do you notice? We noticed that the length are different, right? From the point of dilation. So the distance from here to here to A prime is different than the point of dilation to A. Substantially, they're half. So the corresponding sides are all, the length are different but have the same. But the ratio for all of them are the same though. So we know that the length are different. But when we put it into a fraction as a ratio to compare them, but as a ratio, if you see the ratio here, they're all equal to 2. But as a ratio, they are all the same. Okay, what else is the same? The angles are the same. The corresponding angles are the same. So we can also say the shape remains the same, and the corresponding the shape are the same. We didn't change the shape. The shapes are the same, just smaller. The shapes remain the same. Remain the same with the same degree. Remain the same, just smaller. It shrunk or got bigger, dilated, just bigger. In this case, it went from small to big. And the angles are the same, and the angles remain the same. So we call this similar triangles. Okay? They're called similar, they're not congruent. The same but bigger, and the angle, not the angle, you should say the corresponding angles. The corresponding. The correct vocabulary word is corresponding. The corresponding angle remains the same. We want to use the word corresponding, because not all the angles are the same. The corresponding angles, the one that's supposed to match exactly, are the same. Okay? It's really important. Okay, let's go and do problem number 2. So if you do problem number 2, it's very much like problem number 1. So you measure each one. Okay, number 1, how is the distance, how is the ratio distance of image from the center of dilation, the distance of origin from the center of dilation represented? Is the scale factor less than 1, equal to 1, or greater than 1? Explain your reasoning. Well, let's see. Let's read what's 1 greater than 1. I did not expected you. I didn't explain that. Okay, we'll go over it in class tomorrow. This. Okay, so we'll skip number 1 here. Okay, I'll explain it tomorrow. Of what 1 greater than 1 is. It's beginning of your textbook. That I did not explain. It's actually a reduction, not a dilation, because it started out here and it went smaller. That's why it's a reduction, so it's less than 1. This is 1 whole because it's smaller. Anyways, I'll explain it tomorrow. I forgot to explain it in class. Okay, measurement of millimeters. Okay, if you have a hard time counting, remember we did it in class. We measured it, and you can measure with your protractor, and from measurement from point to from DE, this point right here, just measure it with your centimeters. When you measure it with your centimeters, you should get 3. So if you get 3 on your centimeters, a millimeter is just times it by 10 to get that, okay? And then if EF, same thing. EF, if you measure that line segment right there, line segment EF, you should get 44, and then 4 centimeters, and you just add times it by 10 to get millimeters. Same thing with DF. Measure it, and you should get 36, I believe. And if you measure the dilation or the reduction in this case, because you are reducing it, it went from here and then it went smaller, it reduced. So the reduction, DE, if you measure DE on this side, you should get the reduction is 15 millimeters. EF, measure EF, you should get 20 or 2. This is 1.5, and then times 10, you get 15, okay? This is 2, but times 10, you get a 0. And the last, number 3, you measure, you should get about 1.8, right? And times it by 10, because it's millimeters, 18. Okay, and then go to the last page. Measure D prime to P. Okay, D prime to P. That's D prime to P right here. Point of origin right there. You measure that, you should get 4.4, somewhere around there, or 44 here. Times it by 10. Okay, E prime to point of origin, you should get 36. Here you should get 56 millimeter. Okay, now you measure point of origin to D. Should be longer. You can see it's all the way up here. And you should get 88. Here you should get 72. You should get 112. Same thing as the other one, right? Then you write the ratio. This is 44 over 88. F prime okay, you should get each time the same answer. I'm going to have you finish this. Well, okay, I'll record it. You guys don't stop because I stop. I stop because I assume you know it. E to F. Is 20. Yeah, E to F prime, I mean. E to F is 40. E prime to P. Did I miss it? Anyways, E prime P. Oh gosh, I missed it right here. 36 to 72. T prime to E prime. It's 15. D to E is 30. 15 over 30. D prime F prime is 18. D to F is 36. Yes, baby. All reduced to a half, if you noticed.
It's starting to take so long.
Did you eat too much?
Probably.
Did you drink some water?
I ate.
Did you drink water while you eat? Okay, and measure those angles. Practicing measuring the angles, you guys. It should come out, it's the same angles as the other one. Really no different. 75 degrees, 60 degrees, 45 degrees. Okay, same thing. They gave you the same ones. What can we say about the triangles? The ratios are the same. The sides are different size, but the ratios are the same. And the corresponding angles are the same, are congruent. All of them. Okay, that's what you should write here.